Hello and welcome to Neo Psychology with me, your teacher, Mr. Neo, the channel where I teach psychology lessons to my wonderful students. Today, we're starting a new topic, which is Biopsychology, the Year 2 content. We're starting with Lesson 1, Localization of Function in the Brain. Let's get started. Over energetic. Here we go. Biopsychology, localization of function in the brain. What does that mean? We're not even sure what that means at the moment, but we'll go through it together, don't worry, and then we'll get a better understanding. Let's start with the starter. What better place? Here we go. The starter. The brain is subdivided into four lobes or four areas. This diagram of the brain, draw this diagram of the brain, and label the four lobes, right? Draw the diagram of the brain and try and label those four lobes. It doesn't have to be perfect. It's not an art project. Just draw the brain really quickly. Pause the video, draw the brain. If you're needing some help, if you want some support with how for labeling the lobes, we've got keywords. We've got frontal, occipital, parietal, and temporal. Those are some key words. Maybe you can fit them in somewhere. Which one's which color is which section. Pause the video, do a really quick drawing of the brain, and then try and label the lobes. Okay, let's get started. Let's have a look. Let's see if you got these right. Let's see, have a look. The front one, the blue one, the front one, easy, is the frontal lobe. There we go. Easy. That's the frontal lobe. The yellow part is the parietal lobe. Good. The red one, you got any idea? Occipital. Brilliant. Well done. And the green part? Did you say temporal? Absolutely smashed. That's the temporal lobe. Well done. Anyone get the white part? Anyone know what the white part is? Extra points, bonus points. Cerebellum, you say? Brilliant. Great start already. You've impressed me. Here we go. We've got the frontal lobe, which is the blue part. The yellow part is the parietal lobe. The red part is the occipital lobe. And the green part is the temporal lobe. If you've got the cerebellum, smashing it already. Here we go. We've got 4 learning objectives for today. What are our 4 learning objectives? Learning objective 1. Show comprehension of the term localization of function in the brain. 2. To identify the 2 symmetrical hemispheres of the brain. 3. To analyze the motor, somatosensory, visual and auditory centers in the brain. Wow, we've got lots of stuff to do. And 4, apply knowledge of the language area of the brain. Oh, a certain part of our brain is the language area. Where is that going to be? Let's find out. Let's start with learning objective 1. Show comprehension of the term localization of function in the brain. Localization of function refers to the principle that specific functions such as language, such as memory, such as hearing, etc., have specific locations within the brain. That's what localization of function means. Certain functions are localized specifically in specific parts of our brains. The early 19th century witnessed a growth of interest in the localization of function in the brain. It was Franz Gall's theory of phrenology, which is the study of the structure of the skull to determine a person's character and a capacity, was undoubtedly influential, but was quickly discredited. So it's quite an unscientific idea of phrenology, which is similar to our understanding of localization of function. It's sort of where it started, but it was about looking at the structure of someone's skull and the shape of it. And you go, oh, that person's got a massive head. He must be really intelligent. Or, oh, look at that divot in that person's head. He must be some sexual deviant. It's not about that. There was a very crude and unscientific way of understanding people's behavior and understanding people's brain structures. Now we have localization of function. We have a better understanding as time has gone past and as technology has improved. We've got a much better understanding of the brain now. Shortly after, using animal experimentations, Pierre Florenz was able to demonstrate that the main divisions of the brain were responsible for largely different functions. So all these 4 sections here, frontal, parietal, occipital and temporal, he found out, Florenz, oh, they've actually all got sort of different functions. They don't have similar functions. Since Gall and Florenz's day, the techniques have grown considerably more sophisticated as technology has got better, as has our understanding of the functional organization of the human brain. As time's gone by, we've got a better understanding of the brain. Now we've got a much better understanding of what we did before. In the future, we'll probably have an even better understanding. The human brain is surely one of the most complex and fascinating of all biological systems. Or in psychology, I agree, it's the study of the mind and behavior. In this lesson, we discuss the idea that different functions of the brain are localized in specific areas, as well as taking a whistle-stop tour through some of the key parts of the brain. So that's what we're doing in today's lesson. Localization versus holistic theory. What does that mean? What is holistic theory? Well, let's find out, shall we? Well, let's find out. During the 19th century, scientists such as Paul Broca and Carl Wernicke discovered that specific areas of the brain are associated with particular physical and psychological functions. Before these investigations, scientists generally supported the holistic theory of the brain, that all parts of the brain were involved in the processing of thought and action. So, holistic comes from the word whole, right? It's holism, holistic. So essentially, what it was before was, our idea of the brain was, oh, for every single action, for every single physical function and psychological function and every behavior that we do, you use the whole of your brain. It was holistic. It was a holistic theory, use the whole of the brain. But then Paul Broca and Carl Wernicke came about and they were like, well, actually, I don't really agree with that. I think we use specific parts of the brain that help us to do specific and particular physical and psychological functions and behaviors. And that's what they determined. And that's what localization of function means. In contrast, Broca and Wernicke argued for localization of function. This is the idea that different parts of the brain perform different tasks and are involved with different parts of the body. It follows then that if a certain area of the brain becomes damaged through illness or injury, such as a stroke, the function associated with that area will also be affected, and that's how they came to their conclusion. They would find that, oh, this person's damaged this specific part of his brain and now he's lost the function of this. However, when the person damaged a brain on the opposite side, they haven't lost the function, so therefore that part of the brain must be really specific to this function. And that's how they came to this conclusion of localization of function. So here we go, we've got a definition. Complete the definition, it's a gap fill activity. We've got 4 words, let's try and fit them in. I'm going to do it with you. Let's see if I can do it as well. I mean, I made the lesson, so hopefully I should be able to do it. Right, localization of function. The theory that different, what do you think? Areas, yes, of the brain, smashing it, are responsible for different behaviors, processes, or activities. Brilliant. Did you do it as well? You made me do it. Do it yourself. Don't be so lazy. Right, so localization of function is the theory that different areas of the brain are responsible for different behaviors, processes, or activities. I think we've just learned something there, right? We understand localization of function. I certainly do. So there we go. Localization versus holistic theory. Identify one thing you learned about localization versus holistic theory. What's one thing you learned about? Why do you think learning about localization versus holistic theory is important? Why is it important to learn about these things? It's not just to pass our exams, it's to get a better understanding of the human brain. How does localization of function apply in real life? How does this apply in real life? Well, one way would be like if you were to damage a certain part of your brain, it will explain why now, for some reason, you're having trouble with walking, even though you didn't hurt any part of your legs. So that would make sense. It would give us a better understanding of human behavior. And what questions has localization versus holistic theory raised for you? What are you still wondering about? If you've got any questions, write them down, ask me in person, or put them in the comments below, and maybe I'll answer them, or maybe another smart student can answer them. Right. So that was localization of function in the brain. Do you feel like we've showed comprehension of the term localization of function in the brain? I feel like we had. Should we tick that off? Let's go. Smashed it. There we go. That's learning objective 1, done. Learning objective 2, to identify the 2 symmetrical hemispheres of the brain. Ooh, what's that going to be about? Let's find out. Hemispheres of the brain and the cerebral cortex. Lots of technical words, but we'll know what it means. It's cool. The brain is divided into two symmetrical halves called the left, this is my left, and right hemispheres. Some of our physical and psychological functions are controlled or dominated by a particular hemisphere. This is called lateralization. So we understand localization is looking at a specific part of the brain. This part does this part does this part does this. Lateralization is a really similar concept, but it's more broad. It's saying, oh, lateralization, it means a specific, the left-hand side deals with this, or the right-hand side deals with this. As a general rule, activity on the left-hand side of the body, so left-hand side of the body, my left hand, this is my left, do the L's. Left is my L. So, left-hand side of the body is controlled by the right hemisphere of the brain. And on the right-hand side of the body, hello, is controlled by the left hemisphere, the left-hand side of the brain. The outer layer of both hemispheres is called the cerebral cortex, right? It's like a tea cozy. Nobody knows what a tea cozy is. Obviously, you're way too young. Even I'm too young. I'm young enough. What are you talking about? A tea cozy is something that old people, don't be offended if your mum does this, it's not a big deal. A tea cozy, for some reason, old people like to put a little jumper on the teapot, right? It keeps it warm, I think, a bit longer. So you get a little jumper, you put it on the teapot. It's like a tea cozy, right? And that's what I use as the analogy, or what it used in the textbook. The cerebral cortex is like a tea cozy covering, right? Covering the inner parts of the brain. This tea cozy is about 3 millimeters thick and is what separates us from other animals because the human cortex is much more developed, okay? If you have a look in the image, the grey section is the cerebral cortex. It's the outer layer, essentially. The cortex appears grey due to the location of cell bodies, hence the phrase grey matter to describe the surface appearance of the brain. Got another gap fill, right? Let's get those definitions. Do we know them, right? Hemispheres of the brain and the cerebral cortex complete the definition. Let's give it a go again. Hemispheric lateralization. Hemispheric lateralization, good, refers to the fact that some mental processes in the, go on, well done, brain, are mainly specialized to either the left or the right. Anyone know? There's only one left. Hemisphere. Easy, right? Hemispheric lateralization refers to the fact that some mental processes in the brain are mainly specialized to either the left or the right hemisphere. Hemispheric lateralization. We're learning all these well-intelligent words today. You're going to swear well. You're going to sound well smart. Go and talk to your friends about this. Identify one thing you learned about hemispheres of the brain and the cerebral cortex. What's one thing you learned? I'm sure I taught you at least one thing. Remember it. Why do you think learning about hemispheres of the brain and the cerebral cortex is important? Why is it important? Again, this isn't just to pass our exams. It's to get a better understanding of the brain, right? Now we know that certain functions of the brain are lateralized. Now we know, oh, well, the reason why you've got problems in your right arm is because you damage your left hemisphere, and the left hemisphere controls the right arm. Oh, that's really good. Oh, thank you, doctor. You know now. Brilliant. How does hemispheres of the brain and the cerebral cortex apply in real life? How does our understanding of these things apply in real life? And then lastly, again, what questions has hemispheres of the brain and the cerebral cortex raised for you? What are you still wondering about? Put it in an email if you need to. Put it in an email. Ask one of your friends. Send them a text. Have you made the notes for Mr. Neo's lesson yet? You haven't? You're a mug then, mate. That's learning objective 2. To identify the two symmetrical hemispheres of the brain. We can tick that off because we're smashing it. Learning objective 3. To analyze the motor, somatosensory, visual and auditory centers in the brain. Let's get started on that, shall we? The motor, somatosensory, visual and auditory centers. The cortex of both hemispheres is subdivided into 4 lobes, which are named after the bones beneath which they lie. The frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. As we found in the starter, each lobe is associated with different functions. The motor cortex. Cortex is another word for area, but sound really smart and use the word cortex. At the back of the frontal lobe, So this is the frontal lobe. So towards the back of the frontal lobe, which is around here, in both hemispheres, left and right, is the motor cortex or the motor area, which controls voluntary movements in the opposite side of the body. Damage to this area of the brain may result in a loss of control over fine movements. So what they found is we have a motor area or a motor cortex in the frontal lobe. And what they found is if you damage this specific part of the brain, it will affect your movements. As you can see from Carlton from the image, he ain't got no problems with his motor area or motor cortex because his control movements are fine. Yeah, right. Let's fill this one in. No support words this time. I feel like we can do it. Motor cortex is a region of the what lobe? It's the frontal lobe. Good. Involved in regulating movement. Yes, good. There we go. So it's the brown section that you can see in the image just there. Motor cortex. That's what's in charge or involved in regulating movements, apparently. The somatosensory cortex. At the front of both parietal lobes, so next to the motor cortex, is the somatosensory cortex. The somatosensory cortex is where sensory information from the skin, e.g. related to touch, heat, pressure, etc., is represented. The amount of somatosensory area devoted to a particular body part denotes its sensitivity. For instance, receptors for our hands and face occupy over half of the somatosensory area because our hands and our face are more sensitive than other parts of our body. So let's fill that in, right? Somatosensory cortex. It's an area of the parietal lobe that processes touch, sensory or touch information. Oh, sensory information such as touch. Good. I knew that. Visual cortex. The visual cortex in the occipital lobe at the back of the brain is the visual cortex. Each eye sends information from the right visual field to the left visual cortex and the left visual field to the right visual cortex. So that's not the left eye and the right eye, it's the left visual field. So both eyes look on the left and the stuff that we see on the left goes to the right hemisphere, and the things we look on the right, so essentially your nose is the center, so anything to the right of your nose gets processed by the left hemisphere of the brain. This means that damage to the left hemisphere, for example, can produce blindness in parts of the right visual field of both eyes, right? So this has happened before. Sometimes you get in a fight or you've been in an accident and someone's hit you in the back of the head really hard. It can cause temporary blindness because the back of your head, the occipital lobe, is what's in charge with, is what's important with dealing with or processing visual information. So even though your eyes haven't physically been hurt, if the part that manages those images has been damaged, you are blind essentially. You've gone temporarily blind or permanently blind, depends on how hard you hit yourself. Visual cortex. As part of the occipital lobe that receives and processes visual information. So it's the purple section at the back, which is the visual cortex, which is found in the occipital lobe. And the final bit we're looking at is the auditory cortex. Finally, the temporal lobes house the auditory area or cortex, which analyzes speech-based information. Damage may produce partial hearing loss. The more extensive the damage, the more extensive the loss is. In addition, damage to a specific area of the temporal lobe, of Wernicke's area, may affect the ability to comprehend language. So, it's the auditory cortex, which is located in the temporal lobe. So, it's the green section that's labelled in that image there. So, located in the temporal lobe and concerned with the analysis of language or speech-based information. And there we go. We've learned about 4 cortexes: the motor, the somatosensory, the visual, and the auditory centers. Identify one thing you learned about the the motor, somatosensory, visual, and auditory centers. We learned loads of stuff. Just one thing. Why do you think learning about these things are important? How does the motor sensory, somatosensory, motor, visual, and auditory centers apply in real life? How does this help us in real life? How does this help us as an individual, right? We're not learning, it's like when you're in maths all the time, you learn about Pythagoras' theorem. Oh, miss, how's this even going to help me in real life? Well, it does help you in some things. This specifically, psychology is helpful in loads of facets of society, regardless if you go into a world of psychology or not after college or sixth form. And then what questions has this raised for you? What questions has these part of the sections raised for you? You got any questions? Let me know. That's learning objective 3, to analyze the motor, somatosensory, visual, and auditory centers in the brain. Tick it off for me, please. You just got to do a little tick like that. There you go, you've done it. Well done. Right. Learning objective 4, final bit. To apply knowledge of the language area of the brain. Ooh, there's a language area. We learned about all these 4 different areas, but there's a language area as well. Let's find out about that. The language area of the brain. Unlike the areas already discussed, which are found in both hemispheres, language is restricted to the left side of the brain in most people. It's not 100%, but in most people, the language center is actually found in the left hemisphere. In the 1880s, Paul Broca, who was a surgeon, identified a small area in the left frontal lobe responsible for speech production. Damage to Broca's area, so he named it after himself. It's a bit self-indulgent, but, I would do the same, right? So his name was Paul Broca. I found a new area. What are you going to call it? We'll call it Broca's area. Fair enough, Broca. It's up to you, mate. So damage to Broca's area causes Broca's aphasia. Aphasia means impairment of language, right? Which is characterized by speech that is slow, laborious, and lacking in fluency, as seen in a number of Broca's patients, like this individual called Tan, who isn't the individual in the picture, it's a different guy, so called because that's the only word he could use, right? So Broca's aphasia is characterized by speech that is slow and is laborious and lacking in fluency, right? I can't show you the video, so please click on the picture. There's a little video link and it will show you Broca's aphasia. So Broca's area, an area of the frontal lobe of the brain in the which hemisphere, left or right? I'll wait for you to answer. Say it out loud. Yes, left. Well done. Left hemisphere, responsible for speech production. Brilliant. And now there's another area we're learning about. Around the same time as Broca, Carl Wernicke was describing patients who had no problem producing language. So that's different to Broca's aphasia. Broca's aphasia had problem with producing language, whereas Wernicke's people, or Wernicke's aphasia, as we'll find out that it's called, described patients who had no problem producing language, but severe difficulties understanding it. So with Broca's aphasia, they could understand people talking to them, but they had lots of difficulties speaking themselves. But with Wernicke's aphasia, they have difficulties understanding it, but no problem talking themselves. So what they found was Wernicke's aphasia, they had severe difficulties understanding language, such as the speech they produced was fluent, but it was meaningless, right? Wernicke identified a region, again named after himself, Wernicke's area, in the left temporal lobe as being responsible for language comprehension, which will result in Wernicke's aphasia when damaged. Patients who have Wernicke's aphasia will often produce nonsense words, also known as neologisms, as part of the content of their speech. Again, click on the image if you want. It'll open up a video and it'll give you an example of someone with Wernicke's aphasia. There we go. Wernicke's area, an area of the frontal or temporal, lobe in the left hemisphere responsible for what production? Yes, language or speech production. Perfect. Question. Here's a task, right? You've been sat there doing nothing so far. Well, nothing. You should be writing notes, not do nothing. you got to do it for the lesson, so do it. Here's a question. Using your knowledge of localization of function in the brain, because I'm such a good teacher, you should all be able to do this, label the areas of the brain, right? Pause the video now, see if you can fill this in. We've got auditory cortex, Broca's area, motor cortex, somatosensory cortex, visual cortex, and vernix area, right? Give that a go now, please. Give yourself 5 minutes. There's a timer if you want to use that. Click the timer. It'll go around in a circle as a timer would do, as works as you would expect, and it will tell you when the 5 minutes is up. Right, let's go through the answers. Here we go. So, I'm not sure the way in which I put the answers. Okay, so the auditory cortex is found in the temporal lobe. Broca's area is found in the frontal lobe. The other one found in the frontal lobe is the motor cortex, it should be. Motor cortex or motor area. In the parietal lobe, we have the somatosensory area. In the occipital lobe, we use the visual. And the last one, the temporal lobe, is vernix area, it should be. Lovely. Good. Did you get them all right? You did. Well done, mate. Here we go. Identify one thing you learned about the language area of the brain. Well, maybe that is in the left hemisphere. Easy. We will come on to this later, actually. We go more into... I got a lesson coming up. I think it's lesson 6 and 7. We talk about the lateralization, so left and right hemispheres. Why do you think learning about the language area of the brain is important? Gives us a better understanding. Helps us understand vernix and Broca's aphasia better. How does the language area of the brain apply in real life? Well, like aphasia, if you have problems with speaking or you have problems with understanding language, that will help us understand it and potentially come up with ways or solutions to deal with any problems that may arise. What questions has the language area of the brain raised for you? What are you still wondering about? You got any more questions? Let me know. Write them down. Ask them in the class. Ask them in the lesson. Put them in the comments. Answer other people's if you can. And there we go. Learning objective 4, to apply knowledge of the language area of the brain. Let's tick that one off, shall we? Chick. Nice. Plenary. We've got the final task, the plenary now. Easy. Video. Watch the following video of Pinky and the Brain cartoon outlining the areas of the brain, right? Pinky and the Brain. I like Pinky and the Brain. I don't know if you like it. It might be a little bit before your time, but give it a go. It's fun. He goes through all the sections of the brain and makes it into a little song. Again, I think you can click the image. No, you can't. You can click the link below. If you couldn't find any links, it may be in the notes section of the PowerPoint. And there we go. There is the lesson. Right. Make notes for next lesson. So this lesson and next lesson, localization of function in the brain. We carry on with this into next lesson. Use the textbook, pages 156 to 157, to complete your notes. Use other resources if possible. If you have any questions, please feel free to email me at the email address below there. Thank you for joining the lesson today. Today was lesson 1, localization of function in the brain. And I feel like we learned a lot today. Be sure to write up your notes, as I said, for next lesson. Well done, my neo-psychologists. Keep up the brilliant work. I've been Mr. Neo. God bless and peace.
I'm feeling like Will. I feel like a prince. I'm feeling myself. I'm loaded with bills, cause I wasn't blessed with no Uncle Phil. Don't know how it feels. I wanted to flex, they told me to chill. I'm making a flip. My life is a flick, now load up the film.